Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
We've detected 500 of these bursts of radio radiation. Most of them are irregular. They burst once in a millisecond and then they're gone forever.
Voyager 1, which is now in interstellar space, has detected 500 unknown objects over the past 5 years. These mysterious findings come from regions beyond our solar system, where no Earth-based telescope can see. These objects could reveal clues to the universe's deepest secrets. But Elon Musk sees this as an important moment in space exploration. What are these objects and where do they come from? In this video, we will reveal what Elon said about the 500 unknown objects passing by in space. Voyager 1 detected 500 unidentified objects drifting out there in the vastness of space. This discovery has raised a lot of excitement and debate among scientists. The objects seem to have appeared out of nowhere, and their strange formation has left even the most experienced experts scratching their heads. No one knows exactly what they are or where they came from, and that mystery has led to a lot of theories and discussions which Elon Musk is interested in. The discovery was confirmed by Neil deGrasse Tyson, a well-known astrophysicist.
Overturning a previous idea or discovering something that nobody ordered.
His involvement added a lot of credibility to the findings, making the scientific world take the discovery seriously. The objects don't fit into any known category of space discoveries, which has made them even more intriguing. So where exactly did they come from? Stay tuned to find out more exciting details. Initial analysis of the data showed that these objects are unlike anything we've seen before. Some scientists think they might be remnants of ancient cosmic events, like supernovae or collapsed stars. Others have suggested they could be some kind of extraterrestrial technology or debris from distant galaxies. The possibilities are endless, and the mystery has everyone wondering what these objects really are. Others threw out ideas about unknown celestial bodies, maybe things we've never seen before because they come from parts of the universe we haven't explored. Then there were the more out-there suggestions, like the possibility of extraterrestrial technology. Not little green men waving hello, but maybe debris or artifacts from civilizations far beyond what we can currently reach or even imagine. But as with anything this extraordinary, not everyone was convinced. Some scientists were skeptical right from the start. They questioned whether Voyager 1's aging systems might be to blame. After all, the probe was launched back in 1977, and while it's been surprisingly durable, it's still old technology. Could the data be corrupted? Maybe the equipment picked up false readings or glitched out due to its age.
Voyager to turn its camera back towards Earth, and it's what basically amounts to Earth's first ever selfie.
This skepticism wasn't just about doubting the discovery. It was about being cautious, which is pretty standard in the scientific community. You can't just jump to conclusions without ruling out every possible error. Despite the doubts, there was also a strong belief in the reliability of Voyager 1. This isn't a probe that's known for giving faulty data. It's been out there, doing its job for decades, consistently sending back valuable information. Its track record speaks for itself. The fact that it's still operational after all this time is a testament to how well it was built. Many scientists leaned on that history, trusting that the data was genuine, even if it was hard to understand. Voyager's continued relevance in space exploration is kind of amazing when you think about it. It was never meant to last this long, yet here we are, still getting groundbreaking discoveries from it. Voyager 1's longevity is a story in itself. Originally, the mission planners thought it would last just a few years, long enough to study Jupiter and Saturn. But the probe kept going, defying expectations at every turn. It's been almost 5 decades, and Voyager 1 is still out there, sending signals back to Earth. Its resilience is often compared to someone beating the odds in life by surviving and thriving long after people thought they wouldn't. This durability has allowed it to make discoveries that were never part of its original mission. The fact that it's still functioning is almost as impressive as the data it's sending. Voyager 1 isn't just floating around aimlessly either. It's moving at an incredible speed of about 14.5 billion miles per hour. That's fast enough to cover mind-boggling distances as it travels deeper into interstellar space. To give you an idea of how far it is, the signals it sends back to Earth. Despite that massive distance, NASA still manages to stay in contact with it, which is pretty remarkable. The probe continues to send back data that helps scientists learn more about the universe, even from regions that no other human-made object has ever reached. Every year, Voyager 1 covers a large distance of about 3.6 times the combined distance between the Earth and the Sun. That's a lot of space to cover, and even though it's expected to slow down over time, it's still outpacing anything else we've ever launched. The slowdown is due to the lack of propulsion and the weakening pull of gravity as it moves farther from the Sun and other celestial bodies. But even as it loses speed, it keeps venturing into parts of the universe we've never explored, gathering data that's invaluable to our understanding of space. Of course, with a machine this old, there are concerns about the accuracy of the data. Some experts worry that the aging systems could cause errors, leading to false readings. Voyager 1's hardware wasn't designed to last this long, and while it's impressive that it's still functioning, there's always a risk that the equipment might malfunction. Aging components can send back corrupted signals, making it hard to tell what's real and what's just a technical glitch. Despite these worries, Voyager's systems were built with redundancies in place to minimize such risks. The probe's designers anticipated potential failures and created backup systems to keep it operational even if something went wrong. Voyager 1 has earned its place in the history of space exploration. It's become a symbol of human curiosity and determination, proving that even something built decades ago can still make significant contributions. Its ability to continue functioning and sending back data after so many years in the harsh environment of space is nothing short of incredible. And now with the discovery of these 500 unidentified objects, it's added yet another chapter to its already legendary journey. Part of Voyager 1's impressive endurance comes from its technical design. It has a dual redundant computer system, which basically means it has backups for its critical functions. If one system fails, it can switch to another, ensuring that it keeps running smoothly. Two of the key subsystems are the Flight Data System, FDS, and the Attitude and Articulation Control System, AACS. These systems help the probe stay stable and make sure it can continue to send accurate data back to Earth. Without them, Voyager wouldn't be able to maintain its orientation or manage its data effectively. Redundancy is a big deal in space exploration. When you're sending a probe billions of miles away, you can exactly send a repair crew if something breaks. That's why engineers design these systems with backups, so if one part fails, another can take over. Voyager 1 can even reactivate parts of its computer system that were turned off, which has been crucial in extending its lifespan. This kind of design thinking has kept the probe operational far longer than anyone expected. The hardware itself is pretty straightforward compared to modern technology. Voyager's systems rely on hardwired logic, which means they don't depend as much on software that could glitch or become outdated. This simplicity reduces the chances of errors and makes the probe more reliable over time. The lack of complex software has actually been an advantage, allowing Voyager to perform consistently even after decades in space. Voyager 1 has 6 onboard processors, organized into 3 dual channels to manage data efficiently. These processors handle everything from navigation to data collection and communication with Earth. Despite having far less computing power than even a modern smartphone, these processors have managed to keep Voyager running smoothly all these years. Managing Voyager systems isn't easy, especially with the communication delay. Because it's so far away, any command sent from Earth takes over 20 hours to reach the probe. That means engineers have to anticipate problems before they happen and come up with solutions well in advance. They can't just react to issues in real time. This proactive approach has been key to keeping Voyager functional for so long. The team has to think ahead, planning for every possible scenario to make sure the probe continues to operate. Get ready for the most epic moment of the video. Challenges faced by Voyager 1 and the solutions. One of the biggest challenges Voyager 1 faces now is managing its limited power supply. The probe relies on radioisotope thermoelectric generators, RTGs, which convert heat from decaying plutonium into electricity. As the plutonium decays, the power output decreases, which limits what the probe can do. Managing this dwindling power is one of the toughest tasks for NASA's engineers. They have to be incredibly careful about how they allocate power to different systems, making sure the most critical instruments stay operational. To deal with this, scientists developed a continuous power management strategy. This involves carefully deciding which systems need power the most and shutting down those that aren't essential. It's a delicate balancing act, and they have to make regular adjustments based on the probe's current needs. The goal is to keep Voyager running for as long as possible, even as its power supply continues to decline. As the power levels drop, Voyager can't run all its instruments at once like it used to. Engineers have to prioritize which scientific instruments remain active, depending on the mission's objectives at any given time. This selective operation ensures that the probe still collects valuable data.
From a scientific standpoint, what's critical about Voyager today is the record of data that it's taking.
Even though it can't do as much as it could when it was newer. Managing Voyager's power situation is like being out in the wilderness with limited supplies. Every bit of energy counts, and if it's not managed carefully, important systems could shut down permanently. The engineers have to be constantly finding new ways to keep the probe functioning despite the challenges. To keep Voyager 1 running after all these years, NASA had to get really smart about managing its limited power. The spacecraft relies on radioisotope thermoelectric generators, RTGs, which produce less electricity as time goes on because the plutonium inside slowly decays. This means the team had to find ways to make the most of the remaining power without compromising the mission. The first major move was deciding which systems were absolutely necessary and which ones could be turned off to save energy. Engineers started by carefully evaluating all of Voyager 1's systems. Some instruments, especially those that had already completed their missions or weren't useful in interstellar space, were identified as non-essential. These systems were powered down to conserve energy. This wasn't an easy decision because every piece of equipment was originally designed for a specific purpose. Shutting down scientific instruments meant accepting that certain types of data would no longer be collected. But to keep the spacecraft alive, sacrifices had to be made. The goal was to balance the loss of some data with the need to keep critical systems like communication and navigation running. Turning off heaters was another tough but necessary decision. Voyager 1 was built to operate in the cold vacuum of space, but some of its instruments rely on heaters to maintain optimal temperatures. As power became scarce, engineers decided to shut down some of these heaters, even though it meant risking equipment failures due to the extreme cold. Surprisingly, many components continued to work just fine, even in colder conditions than they were originally designed for. The spacecraft's design turned out to be more robust than anyone had expected, allowing it to survive despite these power-saving measures. Deciding which systems to turn off wasn't done on a whim. It required careful analysis and collaboration between engineers and scientists. Each system's importance was weighed against the amount of power it consumed. There were long discussions and debates about what data was still valuable and what could be sacrificed. This process wasn't just technical, it was emotional too. Scientists had dedicated their careers to some of these instruments, and turning them off felt like saying goodbye. But in the end, data and logic guided the decisions. Every watt saved meant extending Voyager's life just a little bit longer, which was the ultimate priority. These decisions weren't made in isolation. Teams at NASA's Jet Propulsion Laboratory worked together, using detailed models and simulations to predict how shutting down certain systems would affect the spacecraft. They had to think not just about the immediate impact, but also how these changes would play out over the next several years. It was like a giant puzzle, with each piece affecting the others. Engineers ran countless tests, double-checking their calculations before making any changes to ensure they wouldn't accidentally cause more harm than good. Even with all these tough choices, the power-saving strategies worked. Voyager 1 kept going, sending back valuable data from parts of space no human-made object had ever reached before.
NASA says its Voyager 1 probe, the most distant human-made object in the universe.
The spacecraft's resilience is a testament to the ingenuity and dedication of the people behind it. Lessons learned from managing Voyager's power have even influenced newer space missions. Engineers now design spacecraft with more flexible power systems, having seen firsthand how important it is to be able to adapt to unexpected challenges. Power management for Voyager 1 isn't a one-time thing, it's an ongoing process. Space is unpredictable, and as Voyager travels farther from Earth, conditions keep changing. For example, even though the spacecraft doesn't rely on solar power, the decreasing influence of the sun affects its temperature and overall efficiency. Engineers have to continuously adjust power usage to compensate. They regularly analyze data from the spacecraft, looking for signs of trouble and making small tweaks to keep everything running smoothly. Flexibility has been key. The team developed dynamic power management strategies that allow them to shift energy between different systems as needed. If one instrument suddenly requires more power, they can temporarily reduce energy elsewhere. This adaptability has been crucial in dealing with unexpected issues, like system malfunctions or power surges. It's kind of like budgeting money, where you have to decide where to spend and where to save, always ready to adjust if something changes. NASA's Deep Space Network, DSN, plays a big role in this process. They monitor Voyager 1 around the clock, tracking its power levels and system performance. This constant vigilance helps catch potential problems early before they become serious. The engineers can't just flip a switch and fix things instantly, though. Since Voyager is so far away, it takes over 20 hours for a signal to reach it. That's why they rely heavily on planning and anticipation, trying to predict issues before they happen. While Voyager 1 can't be physically upgraded, the way its systems are managed has evolved thanks to advancements in technology. Engineers have learned new methods for optimizing power that didn't exist when the spacecraft was launched. Even though they can't install new hardware, they found ways to tweak the existing systems to make them more efficient. These lessons have also been applied to newer missions, helping other spacecraft last longer and perform better. Balancing scientific goals with power limitations is always tricky. The team has to make hard choices about when to collect data and when to conserve energy. Sometimes they'll turn off scientific instruments for a while to let the system rest and save power. Other times, they'll schedule bursts of intense data collection followed by low power periods. This approach helps stretch the spacecraft's resources, making sure it can keep sending information back to Earth for as long as possible. One of the reasons Voyager 1 has lasted so long is because of its redundant system design. From the start, the spacecraft was built with backups for many of its critical systems. If one part fails, another can take over. This redundancy has been a lifesaver, literally allowing engineers to switch between components to keep things running. In some cases, they've even reactivated systems that had been dormant for years to replace ones that stopped working. Voyager's power comes from its RTGs.
One of the last procedures involves loading onto the spacecraft its power supply,
which have been remarkably durable. Even though the power output has decreased over time, engineers have figured out how to squeeze every bit of energy out of them. They've optimized the way electricity is distributed, making sure that no power goes to waste. This careful management has helped Voyager continue its mission, even as its energy supply dwindles. Another strategy has been the selective shutdown of scientific instruments. Some devices have been permanently turned off because they consume too much power relative to the data they provide. This was a tough decision, especially for the scientists who had worked on those instruments. But by focusing resources on the most valuable systems, Voyager has been able to continue collecting important data about interstellar space. We have more solutions to reveal. Don't go anywhere. Optimization of the communication process. Communicating with Earth requires a significant amount of power for Voyager 1. Because the spacecraft is over 14.5 billion miles away, its signals must travel an enormous distance before reaching NASA's Deep Space Network. The farther the signal has to go, the weaker it becomes, meaning Voyager 1 must use a considerable amount of energy to transmit data strong enough for Earth-based antennas to detect. With its power supply slowly running out, engineers have had to find ways to reduce energy consumption while keeping the spacecraft in contact with Earth. Every bit of power saved is crucial to extending the mission, so they have carefully adjusted the way data is sent to make communication as efficient as possible. One of the ways they've managed this is by compressing the data before transmission. Instead of sending raw, unprocessed information, Voyager 1 systems organize and shrink the data into a smaller package. This reduces the amount of time needed for each transmission, which in turn lowers the power required to send signals. Compressing the data means that even with limited energy, the spacecraft can continue to relay valuable scientific information without overloading its weakening power source. The challenge is ensuring that the compressed data is still useful and contains all the necessary details for scientists on Earth. Engineers have refined this process over time, balancing power efficiency with the need to receive high-quality scientific readings. In addition to compressing data, mission controllers have also modified Voyager 1's transmission schedule. Rather than constantly sending signals, the spacecraft now transmits data at specific times when conditions are most favorable. The Deep Space Network has 3 main tracking stations in different parts of the world, one in California, one in Spain, and one in Australia. These locations allow mission control to stay in contact with Voyager 1 despite Earth's rotation. Engineers carefully plan transmission windows when the alignment between the spacecraft and Earth is best, ensuring that the signals have the highest possible strength. By optimizing the timing, they reduce the amount of energy needed to maintain a stable connection, allowing Voyager 1 to preserve power while still delivering useful data. The spacecraft was also built with insulation designed to protect it from extreme temperatures. Layers of protective material help slow down heat loss, keeping the instruments from freezing. Some of the onboard components also generate a small amount of heat when they operate, which helps maintain a stable temperature. However, as more systems are shut down to save power, less heat is produced. This has led to lower overall temperatures, and engineers have had to carefully monitor which systems can handle colder conditions without failing. One of the biggest concerns is that the extreme cold of interstellar space could cause certain components to stop working properly. Electronics, wires, and mechanical parts all have temperature limits, and prolonged exposure to deep space conditions increases the risk of malfunctions. Some instruments, like the cosmic ray detector, have continued to function even at temperatures lower than originally expected. This has allowed Voyager 1 to keep collecting valuable scientific data despite the lack of active heating. However, other instruments have shown reduced performance due to the cold. Engineers have had to make difficult choices about which instruments to prioritize. Since there is not enough power to keep everything running at full capacity, they have accepted some loss in performance in exchange for keeping the spacecraft operational for as long as possible. By carefully distributing power and managing which systems remain active, they have been able to slow down the effects of the harsh environment. Another challenge is temperature fluctuations. Without active heating, certain parts of Voyager 1 cool down more than others. This uneven cooling can cause materials to expand and contract at different rates, which may eventually lead to structural stress or cracks. Engineers monitor temperature data closely to ensure that no critical components drop to dangerous levels. In some cases, they have had to adjust the way power is distributed to create small amounts of extra heat in key areas. You're on the edge of your seat, and it's about to get even better. AACS as a major determinant of the Voyager's data. After some investigation on the communication issue, the issue was traced back to Voyager 1's Attitude and Articulation Control System, or AACS. This system is in charge of keeping the spacecraft's orientation stable and ensuring the antenna stays pointed at Earth. For some reason, the AACS had started sending its telemetry data to the wrong location. Instead of using the correct system, it was relaying information through an old computer that hadn't been in use for years. Since that computer wasn't meant for this task, the data became unreadable by the time it reached Earth. What made things even stranger was that Voyager 1 didn't activate its built-in fault protection. Normally, when an error like this happens, the spacecraft should recognize it and try to fix it automatically. That didn't happen, which left engineers wondering why. There were several theories about what could have caused the issue. One possibility was interference from cosmic rays or other charged particles. Space is full of radiation, and over time, exposure to these particles can mess with electronics. Another idea was that the spacecraft's hardware was simply wearing out. Voyager 1 has been operating for decades, far beyond its original mission. The harsh conditions of space could have finally caused some critical component to degrade. There was also the chance that a micrometeoroid, a tiny space rock, had hit something important inside the spacecraft. Even a small impact could disrupt internal systems. Some scientists also considered the possibility of software corruption. A tiny glitch in the code or memory errors in the onboard computers could have led to the problem. Whatever the cause, figuring it out wasn't easy, especially with the long delay in communication. NASA engineers had to work carefully to diagnose and address the problem. They analyzed the signals and determined that AACS was sending data to the wrong location. The challenge was finding a way to fix this without accidentally making things worse. Any command sent to Voyager 1 had to be precise because one mistake could potentially cut off communication for good. The team needed to redirect AACS data to the correct location, but they had to do so without disrupting the probe's other functions. The process of fixing the issue was slow, mainly because they had to wait almost 2 days after each command to see if it worked. The Deep Space Network played a crucial role in this process. It consists of large radio antennas located in California, Spain, and Australia. These stations work together to keep track of Voyager 1 and other deep space missions. Because the spacecraft is so far away, the DSN's high-powered antennas are the only way to maintain a connection. The network allows mission control to send commands and receive data, even though Voyager 1 is well beyond the reach of any other human-made object. Without DSN, it would be impossible to troubleshoot the spacecraft or even know if it was still functioning. What made this particular issue even more disturbing was that Voyager 1 didn't enter safe mode. Normally, when something goes wrong, the spacecraft is supposed to switch to a protective mode that prevents further damage. That didn't happen in this case. Everything else on the probe was still working fine. Aside from the strange data transmission, in over 4 decades of operation, AACS had never shown this kind of error before. Engineers expected some level of aging and malfunctions, but this problem didn't match anything they had seen previously. It also raised concerns about whether more unexpected issues could happen in the future. Keeping an old spacecraft running is a difficult task, and Voyager 1 presents unique challenges. Since it was launched in the 1970s, its technology is outdated by modern standards. Engineers working on it today must deal with hardware and software that were developed decades ago. There are no spare parts or easy repairs, so every problem must be solved remotely with the limited tools available. Power is also a growing concern. Voyager 1 relies on a nuclear power source that slowly loses energy over time. As the power supply declines, NASA has had to shut down non-essential instruments to keep the probe running. Every year, the spacecraft has less energy available, making it harder to maintain normal operations. Even with these challenges, Voyager 1 remains a valuable mission. It is the farthest human-made object from Earth and is currently traveling through interstellar space. The data it sends back helps scientists learn more about the environment beyond our solar system. Over the years, it has provided important information about cosmic rays, interstellar plasma, and the boundary of the heliosphere. The spacecraft also carries the Golden Record, a collection of sounds and images meant to represent Earth in case it is ever found by another civilization. While its scientific mission is impressive, keeping it operational has become increasingly difficult. Engineers are doing their best to extend its lifespan, but they know that power and resources will eventually run out. Since the spacecraft's power is slowly decreasing, NASA has been looking for ways to make the most of the remaining energy. They have already shut down some non-essential systems to conserve power, but at some point, even that won't be enough. One potential solution is optimizing the way Voyager 1 distributes energy among its remaining instruments. By adjusting power levels more efficiently, they might be able to keep critical systems running for longer. There's also the possibility of modifying how data is transmitted to reduce energy consumption. Since communication requires a significant amount of power, making small adjustments in the way signals are sent could help extend the spacecraft's lifespan. As engineers continue to work through the current issue, they are also preparing for future challenges. Every new problem that arises brings a risk that could end the mission for good. They are carefully considering every possible step to ensure that Voyager 1 remains functional for as long as possible. Do you think the engineers would find solutions to the major issues combating the Voyager? Let us know in the comments section. Do not forget to like this video and subscribe to our channel. Click on the next video displayed on your screen. You will enjoy it.